Good day, ECO235 students. We are continuing with week 4, and you are still busy with topic 2, which deals with nonlinear mathematical problems. But in particular, this week, you will be doing constraint optimization, and you will be focusing on consumption equilibrium. So the prescribed readings is chapter 8.2 of your prescribed textbook. And also for knowledge enrichment purposes, you can consult the Jacques textbook, and that is chapter 5, 5.2.2, and section 5.5, respectively. Now, just some background before we continue. In week 3, in ECO 231, you dealt with consumer behavior, and now we're going to be revisiting the mathematical application of that in ECO 235. So, from your understanding, you know that consumers constantly face decisions that they make on a daily basis, from how many hours they may choose to work or how to allocate the hours of work and the leisure time. We know that from our labor, which is a factor of production, we earn remuneration in the form of wages or salaries. So, as consumers, we now also need to decide how to allocate that income earned to buy various quantities of goods and services, given that we have some limited income and we have to factor in the prices of those goods and services, ultimately, all to satisfy our unlimited wants and needs. Now, from chapter 3 on consumer behavior in micro, it was necessary to examine consumer preferences before we began. And there were 3 assumptions, namely completeness, transitivity, and that more is always better than less. And that imposed a degree of rationality to the consumer's behavior. You were also able to construct your indifference curves to show which combinations of market baskets gave the consumer the same level of satisfaction. You also further learned about utility functions, which is essentially a formula that assigns some level of utility or satisfaction to the individual market baskets. Now, a utility function can be represented by indifference maps. So this is just some background before we jump into the math. So let's consider our utility function here, right? So you're given your utility function and you get a particular level of utility from consuming 2 goods, X and Y. Now, our goal is to maximize our utility or satisfaction. So if I have a utility function, I want to maximize it and find the quantities of X and Y that will maximize my satisfaction. So given that this is a function of 2 independent variables, the first order partial derivatives can be determined, and there are 2 first order partial derivatives. Here we have our marginal utility of X. Now, in order to obtain your marginal utility of X, and here with Y, you need to obtain your first order partial derivative of utility with respect to X. And this is going to be called the marginal utility of X. So this gives us the rate of change of utility with respect to X, while Y is held constant. So here you're having to revisit what you were taught last week about partial differentiation, where you get the first order partial derivative of a function with 2 independent variables. You would first differentiate that function with respect to the one variable and treat the other as constant. Now here we have our first order partial derivative of that utility function, but this marginal utility is with respect to y, treating x as constant. So this first order partial derivative of utility, of the utility function, as I said, is with respect to y, and we call it the marginal utility of y. And it similarly will give us the rate of change of this utility function while x is held constant. Now, certain comments can be made about the shape and the slope of the indifference curve. Now, indifference curves were shown to be downward sloping and convex in shape. The slope varies all along such a curve, and we know that because it is downward sloping, the slope is negative. So the curve must slope downward from left to right, because in order for the consumer to increase its consumption of good X, the consumer is having to give up units of good Y in order to maintain that same level of satisfaction, if you can recall from last week. Thus, we will find that the slope will take large negative values closer to the vertical axis, and as you move along your indifference curve, it becomes less negative, almost zero, as it approaches the horizontal or x-axis. So this function obeys the law of diminishing marginal utility, another important concept to recall. So we can quantify the exchange of goods by stating that the slope of the indifference curve, right, or the marginal rate of substitution is going to be the change in y over the change in x. Or you saw that your marginal rate of substitution of x for y was the negative of your ratio of your marginal utilities, right? So you will recall that the marginal rate of substitution is defined as the maximum amount of a good that a consumer is willing to give up so that they can obtain an additional extra unit of the other good. So this is your slope of the indifference curve, and it's given by the ratio, the negative ratio of your marginal utilities, the marginal utility of x over the marginal utility of y. Now, as the title of this topic suggests, we would like to optimize or find the optimum of a function. But as you learned in section 3.2 last week, or the week prior, there is a budget constraint that consumers face. So consumers have to consider the prices of the goods and the incomes. Now, thus, they face these constraints due to their limited incomes. Hence, in this section of the work, it is referred to as constrained optimization, right? So now, if the prices of the two goods we considered, X and Y, are P X and PY. So PX and PY represents the price of good X respectively and the price of good Y respectively. And if the consumer has some fixed income, and here we're going to use the letter I to denote income, then the budget line can be given by this equation, right? So I, or the income, is equal to the price of good X times X, which is the quantities of good X, plus the price of good Y times the quantities of good Y. So here we have our prices, and that is a subscript X denoting the price of good X, and this is the price of Y, and those represent the quantities, and I represents the income. Now the budget line is a linear function, so the slope is going to be constant, right? And the slope is the negative of the ratio of the prices, right? So your budget line is downward sloping and has a negative slope, right? And the budget line is going to show us all the combinations of the goods where ultimately the total money spent is equal to the consumer's income. And again here, you know that your slope of a linear function or your straight line is given by your change in x, your change in y over your change in x. So if this equation were to be rearranged such that it is an equation of a straight line, the slope is going to be given as the ratio of the prices. So it's the negative ratio of the P of the price of good X over the price of good Y. Now, given the consumer's preferences and their budget constraints, we can determine consumers' choices, assuming the choices are made in a rational manner. So, Consumers will choose the combination of goods such that they can maximize their satisfaction given their limited budgets. So, two conditions must be met, and the first condition is it must lie on the budget line, the point that will be chosen, and it must give the consumer the most preferred combination of goods. So that ties into the consumer's choice based on that there is a budget constraint, but they want to maximize their satisfaction. So this maximum point of the constraint problem that we're facing occurs at the point of tangency. So you know, point of tangency is when these two curves touch at a point. So at this point, the slope of the budget line is going to be equal to that of the indifference curve, right? So at equilibrium, if we have a look over here at equilibrium, the indifference curve, as I said, is tangent to the budget line, and hence the MRS, the marginal rate of substitution of X for Y, is equal to the ratio of the prices of X to Y. So the two curves are going to have the same negative slope, where the ratio of our marginal utilities, which is our MRS, so the ratio of our marginal utilities is going to be equal to the ratio of the prices. So let's have a look graphically what our consumption equilibrium would look like. So remember we had two goods, and in this example, you had your good Y. So it would be plotted on the vertical axis, and you had your quantity of good X plotted on your horizontal axis. And we have our indifference curve and your budget line. And the point of tangency is at point E. So Y1 and X1 indicates the quantities of Y and X that is going to maximize this consumer's utility given this budget constraint. So graphically, we can see our indifference curve is convex in shape, and it has a negative slope, so it slopes downward from left to right. Okay, and the slope is given by the marginal rate of substitution. So I've already mentioned that the slope of the indifference curve is steeper or more negative closer to the vertical axis, and it becomes less negative as we move down along the curve. So the marginal rate of substitution becomes less negative, becomes closer to zero, and the MRS falls or diminishes along the curve. Now your budget line or budget constraint, it is a straight line function, and again it is downward sloping, so that tells us that the slope must be negative. The vertical intercept over here, it represents an instance where the consumer could spend the entire income only on good Y. So that vertical intercept would indicate some quantity of good Y where the full income is spent on just that good, but nothing of good X. And the horizontal intercept over here reflects a scenario where all income is spent on good X respectively. So at point E, that is the point where the consumer maximizes satisfaction. So you can see the budget line and the indifference curve touch at a point, and they are tangent at that point. So no higher satisfaction can be obtained. Remember, you have to be on a point on this budget line because you are constrained by your income and the prices of the two goods. And an indifference curve that lay below or above, if it were above, it would not be attainable, and below, if it were to intersect this budget line, it wouldn't be the highest indifference curve that is attainable, right? So hence this point E represents that the consumer is maximizing their satisfaction. And at this point E, importantly, the marginal rate of substitution, which is your ratio of your marginal utilities, marginal utility of good X over your marginal utility of good Y, is equal to the ratio of the prices of the two goods. So the price of good X over the price of good Y. So Here we will look at how you may be assessed. I will continue with this in part 2 of the slides.